let's start in here. First of all, let's see, today's the 2nd, so March 2nd. A linear inequality is, first of all, let's go and get this written in here. So write this down. It is similar to a linear inequation or linear equation. So it is similar to a linear equation, but uses an inequality symbol. And the inequality symbols are those greater than or less than or greater than or equal to or less than or equal to. Those are our inequalities. And we'll be doing a lot of stuff down here, filling some things out on how to do that. And then on the second page, it's just a bunch of graphs. I'm hoping that we'll be able to get through this pretty quickly because making these graphs, like I said, is really similar to what we did with graphing linear equations. And we're not doing 2 of them, we're just doing 1. Tomorrow we'll graph 2 of them on the same coordinate grid, but today we're just starting off with 1. All right, so the solution to a linear inequality is a little bit different than the solution to a linear equation, because with linear equations, there was one answer because it had to be equal to it. If we're talking about greater than or less than, there's a wide range of possibilities for answers. And so the way that we're going to write this is the solution to a linear inequality is all of the ordered pairs. And ordered pairs, again, are just x, y coordinates. So they're all of the ordered pairs that make the inequality true. All of the ordered pairs, the x, y coordinates that make the inequality true. So the first thing we're going to do today is just do some very quick testing of points, just so you can see how these linear inequalities work in terms of numbers, and then you're going to see how they work in terms of graphs. So our first example here says to determine which ordered pairs are solutions of or to the linear inequality below. So our linear inequality is right here. 2x minus 3y is less than 15. So instead of being equal to 15, it's going to be less than 15. And the first values we're told to use are 2 for x and 5 for y. So what we're going to do is we're going to substitute in 2 for x, and we're going to substitute in 5 for y, and then we're going to see if that works once we end up solving that. So we're going to write this. 2 times the value of x, which is 2, minus 3 times the value of y, which is 5, is less than 15. So we're just writing this exact same inequality, and then we're going to do the math on the left, and we're going to compare it to 15 and see if this is a true statement or not. So 2 times 2 is 4. Negative 3 times 5 is going to be a minus 15. And we're going to say less than 15. We're not solving an equation here because there's no variables left. Once we plug in for the numbers, we're not dealing with variables. We're just comparing 2 values. 4 minus 15 is negative 11. And so this says negative 11 is less than 15. Is that true? Yeah. Negative 15 is, or negative 11 is definitely less than 15. So the answer to this one is yes. 2, 5, if we plug in 2 for x and 5 for y, that creates a true statement. That inequality is true because negative 11 is less than 15. The next one we're going to test is negative 1, negative 7 with the same equation. So instead of 2 for x and 5 for y, we've got negative 1 for x and negative 7 for y. So we're going to say 2 times negative 1 minus 3 times negative 7 is less than 15. And we do the math on the left. 2 times negative 1 is negative 2. Negative 3 times negative 7 is positive 21, so plus 21, and then less than 15. Negative 2 plus 21 is 19, and this says 19 is less than 15. Is that true? No, 19 is not less than 15. It's more than 15. So this answer would be no. Because 19 is not less than 15, that means that the point -1, -7 is not a solution to that inequality. All right, let's try a couple more here. So 3, -4 will be our next numbers that we plug in. So we'll have 2 times 3 minus 3 times -4. And we'll say that is less than 15. 2 times 3 is 6. -3 times -4 is +12, so plus 12. And then less than 15. 6 plus 12 is 18. And this says 18 is less than 15. But 18 is not less than 15, so that's not true. So the answer to this one is no. The 3, -4 is also not a solution to this inequality. And when we talk about points on a graph, I'll show you what I mean by that when we actually start graphing these in terms of which points actually work. And then the last one we're going to check is the point 0, 0. So we're going to have 2 times 0 minus 3 times 0 is less than 15. 2 times 0 is 0. -3 times 0 is 0. So that says 0 minus 0 is 15. Well, 0 minus 0 is just 0. And 0 is definitely less than 15. So that last one there is yes. So if you're asked to find out if an ordered pair, if an XY coordinate works with an inequality, just plug in those numbers for X and Y, see if it works. All right, the main part of today's lesson, though, has to do with graphing these. And when we graph these, it says that graphing linear equations is a way to show all of the ordered pairs that are solutions. And we've got 3 main steps to graph. So the first step is the first step of graphing a linear equation, and that would be to put the inequality in slope-intercept form. That is y equals mx plus b. What that means is solve for y, get y by itself. We always do that with equations. We're always going to do that with inequalities. Now, there is something down right below here. It says, be sure to flip the inequality symbol if you multiply or divide by a negative number. Now, we did this back in Algebra 1A when we were just solving inequalities. We had solving equations, and then we had solving inequalities. And if you have to multiply or divide by a negative number to get a variable by itself, that inequality symbol flips over. And I'll remind you about when that happens and what that looks like. But that is something to keep in mind that we learned back in the first trimester. All right. Now, in terms of how to graph these, there are different types of lines that we will use depending on the type of symbol we have. So if you have a less than or equal to or a greater than or equal to, so basically if there's a line underneath your inequality, you are going to graph using a solid line. And the best way that I remember to do this is if there's a solid line under your inequality symbol, you're going to graph using a solid line. Solid line, solid line. If you have just a greater than or just a less than symbol, does anybody know? Has anybody seen this before? Yeah, what kind of line are we going to use here? What is it? A dotted line, yeah. That would be a dotted line for that one. So if it's just greater than or just less than, we use a dotted line or dashes. We don't just do a solid line all the way through. If it's less than or equal to or greater than or equal to, if there's a line underneath it, we do make just a solid line. And because we're talking about parts that are greater than or less than, and we're talking about a graph, that means we're talking about an area of the graph, above the line or below the line. So all the numbers that are like below that particular line or above that particular line. So when we graph these, not only do we have 2 different types of lines, we are also going to shade in part of the graph. And when we shade in part of the graph, we're saying that all this part of the graph, all those points are answers because we're talking about greater than or less than, which means it could be an area above or an area below that line. So if you have a greater than or equal to, do you think you would shade above the line or below the line if something is greater than? When you think greater than, do you think up or down? Up. Yeah. So you shade above the line for greater than or equal to. And so if you have a less than or a less than or equal to, I usually think down, which is true here as well, shade below the line for those ones. So we are going to walk through these steps and we're going to go over maybe all of these problems. We'll see. So our first example here says 2x minus 3y is less than 15. Hey, I feel like we already used that one, and we did. It was the one that we used up here with the numbers. So we're going to graph that one, and we're going to see what this ends up looking like. So first thing we have to do, we have to write this in slope-intercept form. We have to get y by itself. So first thing we do to get y by itself here, we've done this many times now, is to subtract 2x from both sides. So make sure we're writing this down, minus 2x on both sides. And so that'll be negative 3y is less than negative 2x plus 15. We still have to get y all by itself. What is our step here? Great. I was going to say, just check it with the opposite. All right, here, go ahead and take these. You're welcome. All right. So to get y by itself here, what's the next thing we have to do? I guess what's the last thing we have to do? What do we have to do here to get y by itself? Somebody let me know. Yeah, what do we do to get y by itself? Divide by what? Divide by, yeah, negative 3. So we're going to divide everything by negative 3. All right. So when we divide everything by negative 3, I'm going to go back up to step 1 real quick because we're still working on getting this into slope-intercept form. And step 1, underneath it says, be sure to flip the inequality symbol if you multiply or divide by a negative number. Are we dividing by a negative number here? Yes. We are dividing by negative 3. What that means is this symbol here, this less than symbol, is going to flip over, and it will now be greater than. So we're going to say y is greater than, because we divided by a negative, we have to flip that symbol over. And negative 2 over negative 3, the numbers there don't reduce, but because they're both negative and they're being divided, that just means it's a 2 over 3. So 2 over 3x. And then 15 divided by negative 3 is negative 5. So to get this into slope-intercept form, get y by itself, we now have y is greater than 2/3 x minus 5. We had to flip this symbol around because we divided by a negative number. This red negative 3 is what means that we have to flip that symbol from less than to greater than. Kind of like we did back in first trimester when we were just solving these inequalities. All right, the next part is we have to determine what type of line we have. So based on step 2, are we going to have a solid line or a dotted line? So our inequality symbol is here. Does that match up with solid or dotted? All right, thank you. All right, let's get a little feedback. Solid or dotted here? Make sure we're all awake. Or we can just shake our heads or nod our heads. Does it match with solid? No? Okay, does it match with dotted? Yeah. All right. So we got a dotted line. I'm just gonna write dotted. It's always a good idea just to put this here. If you write that down real quick, that's an easy way to remember what type of line you're gonna make. So let's go ahead and get our line on here. It's a dotted line, and it's starting at -5. We're gonna graph this just like we normally would any other line that we've already always done. So we start at -5 on the y-axis. So we head down here, 1, 2, 3, 4, -5 is all the way at the bottom. And then we have a slope of 2/3. So up 2/3. So 1, 2, 1, 2, 3, just like that. And I still need a ruler. So if anybody else needs a ruler, come on over and grab one. And then line it up. And be sure to make a dotted line. Now, if you make a mistake on this, pencils are always great. That way, if you make a solid line and you're like, oops, it needs to be dotted, you can just erase little parts of it. Just to make sure that it ends up being the way it's supposed to be. And so I'm just going to do a dotted line right through there. You can do dashes just like that. And so there's our line right there, a dashed line or a dotted line. What that means is, by the way, what that actually means is any point on this line is not part of our solution. It has to be, in this case, greater than. So every single point that is greater than this line, so does that mean we're shading above or below this line? If it says y is greater than, is it above or below? Above. So we're saying dotted, and then shade above. And so we're just going to shade in everything above this line. And so all that shading up there represents every single answer to this inequality. All the points that are above that line are answers to this inequality. For example, the point 2,5, the one that we first checked right up here, where we said that 2,5 was part of the solution. So if we find 2,5 on this graph, over 2, up 5, yeah, that's part of that shaded part. So that's within that area that we were talking about. The next point was -1, -7. So if we go left 1 and then down 7, which isn't part of the graph, but if it's below the line, which means it's not part of the answers. The third point was the point 3, -4. So if we find 3, -4, 1, 2, 3, 1, 2, 3, 4, that's down here underneath the line, which is not part of the shaded area. And we said no for that one as well. And then the last one, 0, 0, we said yes. And you can see right there, it's kind of in the middle of all that shading. So that point is part of the shading. So it is an answer to the inequality. So those points that we checked out earlier go with this inequality. And visually now we can see how that works. All right. So that's the basics of making this work. And we also had to divide by a negative. So we saw that flipping in this first one. So let's go ahead and go to the second page. Make sure you have this on your paper. Give you a little bit of time to get that down, and then we're going to move on to the second page. So second page. Everything on this second page is similar to what we just did here. It's just a lot of different examples. So if you're still feeling maybe a little bit shaky on your graphing, this is going to be a good day for making sure that you're getting up to speed on that. Now, the first two problems here are already in slope-intercept form. Y is already by itself on 1 and 2. Which means we can just go straight to the graphing. So we need to figure out, first of all, are we looking at a dotted line or a solid line with problem number 1? I want you to check the notes on the first page. Can somebody tell me, are we doing dotted or solid for problem number 1? Second type, dotted, right? So solid or dotted, it's going to be dotted because there's no line underneath the inequality symbol. So dotted line. And this says y is greater than. So are we going to be shading above or are we going to be shading below? Greater than is above. Yes. So dotted above. All right. Now we can go ahead and graph it because it's in y equals mx plus b. So we're going to start at the y-intercept, -5. So from the middle of the graph down 5. 1, 2, 3, 4, 5. I'm going to be pretty quick with the graphing today because we spent a lot of time on graphs. And so then we're going to go up 1 and over 3. That's our slope, up 1 over 3. And then we're going to line that up. And we're going to put our dotted line or a dashed line straight through that. So there's our dotted line, our dashed line right there. And we said we're shading above this line. So then we just go ahead and shade everything above the line. And that is our answer for problem number 1. If you have any questions, please let me know. Interrupt me at any point. That's totally fine. I just want to make sure that we're not moving too slowly, but if we're moving too fast, let me know. Okay, problem number 2. Y is already by itself. That's good. So this time it says less than or equal to. So are we looking at a solid line or a dotted line? So 1 for solid, 2 for dotted. On number 2. Solid. Yeah. All right, solid line. Less than or equal to. Shade above or shade below? Above or below for this one? Less than or equal to? Below. Yep. So solid line, shade below the line. All right. Now we graph this like we would any other line. So we got y equals -2x minus 1, slope of -2, y-intercept of -1. So we start at the y-intercept. It's -1. Put our point right there. From that point, use the slope of -2. That's down 2 over 1, down 2 over 1. So we just follow that pattern. Down 2 over 1. Line up your points. Solid line. And we're shading underneath the line this time. So that would be on the kind of that left underneath side over here. So this is below. Right there. There's our answer for number 2. Yes. Because the solid line means that every point on the actual line is also a solution because it could be equal to it. The dotted line means it has to be above the line. Any point on this line is not part of the solution. So it has to be, because it says it has to be more than, it can go up to the line, but it can't be equal to the line, if that makes sense. And then on the next one here, where it's solid, it can go up to the line, but it could also be equal to that line. So it's like saying you have to be at least 16 years old to get your driver's license. That would be a solid line because you could be 16, but you could also be older than 16. Another example would be, let's say, freezing, above freezing temperature. 32 degrees is freezing. So above freezing would be anything more than 32. So 32 degrees doesn't work for above freezing. 32.1 degrees does. So yeah, just kind of the difference between just less than or just greater than versus less than or equal to or greater than or equal to. All right, now the next 4 problems, 3, 4, 5, 6, we're going to have to get y by itself. So we have to convert into slope intercept. So look at problem number 3. And on problem number 3, we need to get y by itself. So what's the first thing we need to do here on number 3 to get y by itself? Okay, by doing what? Yeah, take away the 5x. Good. So minus 5x from both sides. All right. So that's negative 2y is greater than negative 5x plus 12. What's the last thing we have to do here to get y by itself? Divide everything by what? Negative 2. All right. So we're dividing everything by negative 2. Those negative 2's cancel. I'm going to go back to the first page here real quick. So everything gets divided by negative 2. Right now we're working on step 1. So I'll come back to this in just a second. Right now we're working on step 1. We're getting the inequality in slope-intercept form. But it says right here, be sure to flip the inequality symbol if you multiply or divide by a negative number. We are dividing by a negative number here. We're dividing by negative 2, which means that when we write our final inequality, it's not going to be greater than. We're going to flip it over, and it's going to be less than. So we're going to say y is less than. Flip the symbol around. Negative 5 over negative 2. The numbers don't reduce, but because they're both negative, we can make it just positive. So 5 over 2x. And then 12 divided by negative 2 is negative 6. So y is less than 5 over 2x minus 6. Now we have to decide. Solid line, 1 for solid line, 2 for dotted line. Going solid or dotted this time? Dotted. Yep. So dotted line, it says y is less than. So are we shading above or below? Above or below? Less than is below. Yes. We got a dotted line. We're shading below the line. Graphing this, we're starting at negative 6 because that's the y-intercept. So we go down to 6 on the negative y-axis. 1, 2, 3, 4, 5, 6 right there. And then we have a slope of 5 over 2. So up 5 over 2. We'll do that one more time. Right there. And this is a dotted line. Or a dashed line. There's our line right there, and we are shading below that line, underneath that line. So that's going to be on this side because that would be underneath it. So everything here gets shaded in because that's the underside of that dotted line. All right. That's it for number 3. Let's try number 4. So I'm hoping most of this process should feel pretty familiar. Getting y by itself, graphing a line. Really the only new thing is deciding what type of a line and where to shape. And then remembering if we divide by a negative that we have to flip around that symbol. Other than that, it's kind of the same thing that we've been doing with our linear equations. All right, so first thing I'm going to do in number 4, I'm going to put a 1 with the x, because that would be 1x. And what do we have to do here to get y by itself? First thing, what do we do? Got to get y by itself. So first thing we have to do on this one is what? Yeah, take away 1x. I know a lot of people in here know that. We just don't like talking. I get it. So take away the 1x from both sides. So that'll be negative 4y is less than negative 1x plus 8. All right. Now we have to divide everything by negative 4. And because we're dividing by a negative, what does that mean? Flip that symbol around. So it's going from less than to greater than this time. So negative 4's cancel out. And so now y is greater than negative 1 divided by negative 4 is positive 1/4. So 1 over 4x, and then 8 divided by negative 4 will be minus 2. All right. Now we have 2 decisions to make. With the type of line, is it solid or is it dotted? 1 for solid, 2 for dotted. Dotted, good. So dotted line. And then are we shading above this one or below this one? Above, because it says y is greater than. Good, so above. So graphing this line, we start at the y-intercept, -2, right here. And then we have a slope of 1/4. So that's up 1 over 4, up 1 over 4. We've got another dotted line here. And this time we are shading above that line. There's our answer for number 4. So all the points that are above that line are answers here. Kai, yeah, what's up? What about pattern call? It has to do with whether or not there's a line. Oh, yeah. So this one here. There. All right. So any questions so far? Hopefully we're doing okay with this. I know I'm moving a little bit quickly, but we've graphed a lot of lines. All right, number 5. First thing I'm going to do, put a 1 with the x and a 1 with the minus y. And the first step to get y by itself on this one, same thing as the last step, minus 1x from both sides. So subtract 1x, subtract 1x. And that'll leave us with the -1y is greater than or equal to -1x plus 8. Last thing we need to do here, divide everything by -1. So again, we're dividing by a negative. We're getting a lot of practice with flipping things over. Because when you divide by a negative, you have to flip the symbol around. So it's not going to be greater than or equal to. It will be less than or equal to. It doesn't change the or equal to part. It just changes the direction of the inequality. So we're not taking away the line underneath, nor did we add a line underneath on these ones. We're just changing the direction of the inequality. And so -1 divided by -1 is just +1. So that'd be 1x. And then 8 divided by -1 is -8 or -8. All right, this time. 1 for solid, 2 for dotted. Solid or dotted? Solid this time. All right. It's a solid line because we have the line underneath the inequality. If you have a solid line under the inequality, you will have a solid line on your graph. So solid line, solid line. Y is less than or equal to. So are we going above or below for our shading? Below this time. Good. And we're going to start our graph at the y-intercept, which is -8. So right here. And then a slope of 1 is up 1 over 1, up 1 over 1. And so this is going to be a solid line straight through. And we are shading below the line this time, so underneath. So it's that area down there. That is our answer for number 5. All right. 6, 7, and 8. 6 is going to be going to take longer than 7 or 8. 7 and 8 are going to be real quick. I'll explain why when we get there. Number 6, 3x plus 2y is less than 0. So first thing we have to do, so we're got to get y by itself again on this one. We're going to subtract 3x from both sides. So minus 3x, minus 3x. Now, because 0 was the number over here, we don't have to write -3x plus 0. We could just write -3x. So I'm going to say 2y is less than -3x. And this time, to get x by itself, we're going to divide everything by 2. We did not divide by a negative on this one, which means we will not flip around the symbol. If you don't divide by a negative, don't flip the symbol around. So it's going to stay less than. Negative 3 over 2 does not reduce, so that's just negative 3 over 2x. So this says y is less than negative 3 over 2x. All right. 1 for solid, 2 for dotted. What are we doing? Solid or dotted? Dotted line this time. Okay, so dotted line. Less than, above or below? Below. Yep. We're shading below this time. Okay. And what's our y-intercept? Where do we start on this one? At 0, yeah. There's no number after this, so that means it's going to be 0. Now, you could have put the plus 0 the whole time, or you could put plus 0 at the end here if you want to. Doesn't make a difference. The y-intercept is going to be 0, so we start right in the middle of the graph. And from that point, it's negative 3 over 2, so that's down 3 over 2, down 3 over 2. So we've got a dotted line this time. There's our dotted line, and we're shading below that line. So there's our answer for number 6. All right, our last 2 questions. Here we go. Last 2, we got y is less than or equal to negative 4, and we have x is greater than 7. Now, these last 2 have some similarities to each other. Does anybody remember what happens if you have y and then just a number and then x and just a number? So if it's, what's that? Yeah, and I see, yeah, vertical or horizontal, exactly. So if it's y is just a number, this is going to be horizontal. I'm going to write horizontal there for the y, and then on number 8, if it's x and just a number, it's vertical. So I'm going to say vertical here, just as a reminder that those are the types of lines that we're going to be drawing. There's no slope, there's no y-intercept that we have to deal with. Well, there might be a y-intercept, but there's no slope that we have to deal with on either one of these. But we still have to make decisions about dotted or solid and then above or below. So on number 7, 1 for solid, 2 for dotted. Going solid or dotted? Let's see solid. Okay, good. So solid. And it says less than or equal to negative 4. So would that be above or below? If it's less than or equal to, above or below? Below. Yep. So below. Solid line, shade below. And the nice thing about graphing a horizontal line is you just go to the y value here on the y-axis, negative 4. So that's down negative 4. Put your point, and because it's a horizontal line, we don't need to worry about a slope. We just draw straight from left to right, and this is a solid line. And so there's our y at negative 4, and then because it's less than or equal to, we're going to shade below that. So that's our answer for number 8, or sorry, number 7. And then our last problem on here, x is greater than 7. We're saying that's a vertical line. What type of line? Are we going dotted or solid? Dotted line. Yep. Sorry, solid or dotted. Solid was 1, dotted is 2. Dotted line for this one. So dotted line. And then are we shading above or below? This is going to go above. Above is going to look a little different, though, when we have a vertical line. I'll talk about that in a second. So we have dotted line, it's above. We're going to go to the x value of 7 this time because it says x is greater than 7. So if we go over 7 on the x-axis, 1, 2, 3, 6, 7, we put our dot right there. And then we're going to draw a vertical line vertical dotted line straight through that. There is our dotted line. Now, because it's greater than, we're saying above, but because it's vertical, there isn't really above. So when we're talking about greater than on the x-axis, are we talking about greater than this way or greater than this way? Which way is greater than? Yeah, greater than would be to the right. So when we're talking about above here, that's shading to the right. So if it's a vertical line, there's a little bit of a difference when we're talking about above a vertical line, because you can't literally go above a vertical line. Above means positive direction on the x-axis, so to the right. That's everything over there. And that's everything for your notes today. So we've got a little more than 20 minutes to get started on the assignment. That's great. That's plenty of time. So